All right, to find critical numbers, as a reminder, we need to find the derivative and set it equal to 0. And then we can use the second derivative test to figure out if it's a relative maximum or minimum. All right, so for the first derivative here, I'm going to just multiply the exponent by the coefficient. So I get 2 times 3 is 6, and then reduce the exponent by 1. So 3 minus 1 is 2. Here, same idea, -4 times 2 is -8, and then reduce the exponent by 1, and then the derivative of a constant is 0. Second derivative, same thing. So multiply the exponent by the coefficient, we'll get 12, and then x, and reduce this by 1, so we'll get to the first power. And then here, -8 times 1 is -8. Reduce the exponent by 1, which gives me a 0, so I no longer need to write the x. All right, so critical points occur when the first derivative is equal to 0. So we're going to take the first derivative, 6x squared minus 8x, and we're going to set that equal to 0. So we can factor out here an x really easy. And this is going to factor out like this. Now to solve this, you can use the zero product property, which says that for this to be equal 0, either one of these two things has to equal 0. So we can solve here, we'll get x is equal to 0. And for here, we'll get 6 minus 8 is equal to 0, which if we add 8 to both sides, we'll get 6x is equal to 8, and dividing by 6 on both sides, we'll get x is equal to 4 over 3. Okay, so these are our critical points, are 0 and 4/3. All right, so now using our second derivative test, we're going to plug those in to the second derivative. So f double prime of 0 is equal to 12 times 0 minus 8, which is -8, which is a negative number. So this is a relative maximum. And then here, f double prime of 4/3 is going to be 12 times 4/3 minus 8. So 12 times 4/3 is going to be 16. Minus 8 is positive 8, which means that it's going to be a relative minimum. So these are relative minimums, and sorry, this one's a relative max, and this one is a relative minimum by the second derivative test.